Good thing by now. I had to turn off my speakers because you hear that buzz?
I like that buzz.
It's like calming for you. It's not calming for me hearing it hours upon hours. So the speakers are. If someone deserves a button, I will flip on the sound, then do the button, then flip it off again. Anyway, hello, good day, Algebra. We are going over PO22 for a second time. We didn't get very far into it last week. And so just for review, if you weren't here or didn't jot them down, what are the two steps that we covered for converting an equation from slope-intercept into standard form? Okay, actually, let's go way back up at the top. Slope-intercept form, we know this, we love this, we've covered it before. Y equals mx plus b. Standard form is what? This is the new one. James?
ax plus by equals
c. Ax plus by equals c. Is the b in slope-intercept form and the b in standard form the same?
No.
No. That's why one is lowercase, one is capitalized. What's the quirk of standard form that we need to remember here? What's kind of quirky about it? There's a condition that we must follow. Interrupt me when you know it. Yeah.
A, B, and C are integers.
Right. Standard form cannot have any decimals, cannot have any fractions, which is why when we have a fraction in slope-intercept form, which you often will because slope is a fraction, we have to undo that, right? So what were the two steps? What were the two steps that we wrote down for converting something from slope-intercept into standard? Aiden, first one.
Multiply each term by its denominator.
Right.
Or else.
Multiply each term by the denominator. And I think I put this in red. Well, or LCD. And LCD stands for least common denominator, right? And that's going to come into play when we have two fractions, like we do in that example there. Okay, but multiplying each term by the denominator undoes the fraction, right? Undoes the fraction. What was step 2? I think James is the only one who wrote these down. Oh, you got it? James.
Using opposite operations, move the x term to the other side.
Yes, using opposite operations. And we use opposite operations because we're moving something, right? We're taking a term from one side of the equation, putting it on the other side. Move the x term to other side of equation. Okay? Using opposite operations, move the x term to the other side of the equation. And then you're done. Then you will be in slope-intercept form. So this first one we did together, we don't have a fraction here. Y equals 4x plus 7, so we can skip step 1. We move straight to step 2, which is move that x term to the other side. And that is why on your page, you should have a minus 4x. Because the opposite of a positive 4x is a negative 4x, right? That's how we move it from one side of the equation to the other. We have 4 on one side. We take those 4 away. We have to take 4 away from the other side as well to keep it balanced. We can't just move it there and say 4x plus y, right? Because now the equation has changed, okay? We have to keep it balanced. Why can't we combine our y and our negative 4x term? This came up as well last week. They're different variables, right? They're not like terms. We have to keep them separate. That's why in standard form, it's got an ax and a by term that are separate. Okay, we have to keep those terms separate. So negative 4x, because if you have no x's and subtract 4, now you have negative 4. Negative 4x plus y equals 7, which is what we have left on the right side after those 4 x's cancel out. Okay, that's the gist of it, right? Questions? Again, this is review. This is recap from last time. Okay, the next one, we do have a fraction. What do you have written down? What did we do? What did you do? The door's open. Well, who moved it? Emily literally just checked it to make sure the thing was in there. Who moved it? Well, someone did, because right before I started recording, Emily checked it and it was there. I saw it. Someone didn't fall. Someone moved it. Which one of you Moved it.
I didn't move it when we're inside. I was just like
Yeah,
putting
you
it outside.
Right, so you moved it.
Yeah.
Okay, there we go. What do you have written down on your page for what to do when you have that fraction 3/2? Mario.
So obviously you multiply by each term by the denominator.
Yes, you multiply each term by the denominator, which in this case is 2. So we multiply the 3/2 by 2, multiply the -5 by 2, even the y gets multiplied by 2. And how does the fact of multiplying by 2, how does that cancel out the fraction? Mathematically, what's going on here? Gus?
Because then the fraction is going y, so it'll be 6 over 2, and then like 6 divided by 2 equals 3.
Yeah, what happens when you multiply 3/2 by 2, you're really multiplying by 2 over 1, right? And not only have you learned before, if we have a 2 in both the numerator and the denominator, right, here they can cancel out, leaving you with 3 over 1. Or if you actually multiply it out, 3 times 2 is 6, 2 times 1 is 2, 6 divided by 2 equals 3, which is the numerator, okay? So either way, whether you cancel them out or you actually multiply it out and simplify, you're going to get whatever the numerator is. And that's how it works. So now we have 2y equals 3x. -5 times 2 is -10. We've gotten rid of the fraction. We're not quite done yet. Second step is move that x term over. So we subtract 3x from both sides. And your answer should be -3x plus 2y equals -10. Check that -10 on the right side. Make sure you brought that sign with it. That sign belongs to it. Okay? So -3x plus 2y equals -10. I think that's as far as we got together the last time. You were to do the next 3, I think, for homework. So we'll go over the answers to those, and then we'll tackle what happens if you have a double denominator. But questions on what we have here? Okay. Who is feeling? Do you have to do all of these, or just the next row?
Like the middle.
Just the middle row. Okay. Who's feeling bold and brave and wants to share with us their answer for the first one? Y equals 12x plus 2. What did you come up with? Emily.
-12x plus y equals 2.
Good job. Okay. -12x plus y equals 2. The only step to do here is to move that 12x over. Again, using opposite operations. If it's positive 12x on the right, you are subtracting 12x from both sides. And no x's minus 12x's is -12x, separate from the y term. These cancel out, and you're left with +2. Okay. Question?
I just wanted to do the next one.
Next one. What did you come up with?
5x plus y equals -3.
5x plus y equals -3. Okay? Yeah. This time that x term is negative, so to move it over to the left side, you have to add it, right? The opposite of a -5x is a positive 5x. -5 plus 5 equals 0. This sign, Gus brought it down with his constant, -3 on the right side there. On the left side, you have no x's, you add 5, now you have 5 x's, and then plus y equals -3, okay? The last one has that fraction. What did you get as an answer? Emmett.
-4x plus 5y equals
Thanks, Darth. -4x plus 5y equals -15. To do this, you multiply by that denominator, right? Multiply everything by 5. That cancels those 5's out, leaving you with 4x. So now your equation reads 5y equals 4x minus 15. And then Emmett's second step was to move that 4x over using opposite operations, subtracting it, and that's where you get the -4x on the left plus 5y equals -15. Success?
Say what?
Feeling good? We did. Let's go back up one there. Y equals -4/5 x minus 3/10. Now in our steps, the first step is to multiply each term by the denominator or the LCD, which stands for least common denominator? Why can't we just multiply everything by 5 here? Because both the denominators aren't 5. Multiplying by 5 will cancel out the 5 here, but our second fraction, 3/10 times 5 over 1 gives us 15/10. That's not extremely helpful. Okay? So, what is the least common denominator between 5 and 10? 10. Okay? Essentially the least common multiple of 5 and 10. If we multiply everything by 10, y times 10, negative 4/5 times 10, negative 3/10 times 10, magic happens. Okay? You have to be a little bit careful though, because does this 10 and that 5 straight up cancel out? No, because one's a 10 and one's a 5. Okay? So for this multiplication here, you might have to write it out to see what happens. Negative 4/5 times 10 over 1. Negative 4 times 10 is negative 40. Looks like it's a 6. Negative 40. 5 times 1 is 5. What's negative 40 divided by 5? Negative 8. Which is double what the numerator was to start with. And why does that all make sense? That this would end up being negative 8, which is double the numerator we started with. Because 10 is double 5. There's that connection there. There's that mathematical relationship there. Okay? So y times 10 is 10y. Negative 4/5 times 10 is negative 8x. We did the math right there. And then for the negative 3/10, it is a 10 and a 10. So these do end up canceling out, and you're just left with negative 3. Second step, get our x's over on the left to be with the y's. The opposite of a negative 8x is a positive 8x. So adding 8x to both sides, and your final answer is 8x plus 10y equals negative 3. You cannot combine the x and the y term in any way, shape, or form. So it's not 18xy or 18y or 18x, anything like that. Okay, you got to keep them separate. 8x plus 10y equals negative 3. Questions, comments? It is pretty cool. Who said that? Thanks, man. Wow, it is pretty cool. And so are you. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Huh? Oh. Evan?
Do we have to, are you gonna go through stuff again, or can we just do it?
Let's just do it. Let's just go here. So I want you to work on, and I won't erase this work. I'll try and bring it back up there for you to see. But I want you to do the next 3. All 3 of them have fractions, at least one fraction. I'll pause the video, give you like 5-10 minutes to work on these 3. Check your answer with a partner. Then we'll come back and we'll do them together. But I'll leave the work up here for what we did. See if I can line it up correctly here. That's about right? Brilliant. Okay, so you can kind of see what we did up top to help you. So I'll pause the video. We'll come back to it soon. Work on those and TTYL. Okay, all right, here we go. So we've had some time to work on the 3 below. First one, what are you multiplying everything in that equation by? To undo that fraction. 7. Okay, only one fraction to deal with, so everything gets multiplied by 7. We like when there's only one fraction to deal with because it cancels out with the denominator immediately, right? You know that only your numerators are going to be left, okay? When you actually do it, though, the math behind it, negative 2/7 times 7 over 1, okay? And I'm doing the math because we're going to have to do it with the next 2 here, okay? Gives you negative 14 over 7, which equals negative 2, which again is what you would have gotten if you just canceled those out straight away to begin with anyway. That's how it works. Okay, what's that? Okay. So then you've got y times 7, which is 7y. Negative 2 is your coefficient to x now. And then 10 times 7 is a positive 70. Everyone get this far? If not, you see. Okay. Then add 2x. Emily, what did you get?
Why did you get 70?
10 times 7. You have to multiply each term. Every term in the equation gets multiplied. Otherwise, you change the value of it. Okay. So now we're going to add 2x to both sides. We cannot combine our x and y term. They're not like terms. So 2x plus 7y equals 70 is the final answer. How do we do? Looks good? Questions? Evan? Question? Well, if you went terrible, let's figure it out. Do you know where you went wrong? Okay. Alright. Katie, we got a question?
Oh, no, I know this one, but like the next two,
Okay.
I have no idea.
Okay. So, Audrey asked a good question. She's saying, why do we multiply, Priya? Why do we multiply by positive 7 and not negative 7? You could multiply by negative 7 if you wanted to. Okay? What that does, though, is going to change the sign of everything in the equation, which is just more opportunities to make a mistake. Okay? When you multiply by positive 7 and keep just the negative sign with the 2 here, then the signs of everything don't change. If you multiply by negative 7, this becomes a negative 7y, that becomes a positive 2x, that becomes a negative 70. It's a easier to miss a sign. But could you do it if you wanted to? Yes, you could. Okay, the next one. Double fraction, which means we're multiplying by the least common denominator, which essentially means we're multiplying by the least common multiple of 6 and 4. That will cancel both of them out. And what is the least common multiple of 6 and 4? 12. Okay?
What?
So, Tatum, what did you multiply by?
I'll multiply by 4.
6? Okay. So, folks, multiplying by 6 will cancel out the 6. It will not cancel out the 4. That's why we can't do that, or we don't want to do that. Multiplying just by 4 will cancel out the 4, but it won't cancel out the 6. That's why we don't want to do that. The reason why we multiply by the least common multiple is because if we pick a number that both 6 and 4 go into, it will cancel them both out. Okay? So 12 being the LCD of 6 and 4, that is what we are going to multiply by. Okay? And in this case, I highly recommend doing the math. Because if you just start canceling things out, it's easy to miss a step. When you take 7/6 and you multiply by 12 over 1, our numerator becomes 84, and our denominator becomes 6. What's 84 divided by 6? 900?
14.
14. Okay? Now, the connection here is look at, 12 and 6 can't cancel out, right? Because they're not the same. But our numerator was 7 to start with. The relationship between 12 and 6 is that 12 is double 6. And so our final answer is going to be double what the numerator was. Okay? The reason why that happens is because we can rewrite 12 to be 6 times 2. Okay, folks that don't get it, this is when you can't be talking to your neighbor. This is when you need to be focused up here. I'm explaining it. Okay? You can rewrite 12 as 6 times 2, which makes us allowed to cancel out the 6's. And we're left with 7 times 2, which is 14. Okay? Or multiply 7 by 12 to get 84. 6 times 1 is 6. 84 divided by 6 gets you 14 that way too. Okay? But the reason why we multiply by 12 is because that's a number both 6 and 4 can go into. It starts with recognizing what is the least common multiples of 6 and 4. Okay? Doing it with the negative 1/4. We multiply that by 12 as well. Our numerator, negative 1 times 12 is negative 12. 4 times 1 is 4. Negative 12 divided by 4 is negative 3. Okay? So, when we put it all together now, y times 12, that's just 12y. That's the easy one. 7/6 times 12 gave us 14. That's the work behind it. And negative 1/4 times 12, here's the work. gives us negative 3. And now all of our fractions are gone. So I'll stop here. Where have I lost you? What questions do you have?
I did right first.
No, we're not done.
We're not done yet. This is the hard part here, right? So I want to make sure that everyone is in a good spot here. Those that were confused before, do you now see the light?
Kind of.
Or am I blocking it?
Yes.
Tegan.
I'm still kind of confused on how you got the times 12.
So the 12 came from the fact there are two fractions, which means we need to find the least common denominator of those, well, of the 6 and the 4. Which means what's the smallest number that both 6 and 4 can go into? That's where the 12 came from. Okay?
Does it always have to be these?
You can multiply by any common multiple, it just makes your numbers bigger. It makes the simplifying harder. Okay? All right, anything else with this multiplying the LCD thing? Okay. Tatum said we're not done yet. He's correct. X and Y are not on the same side. So our final step, move those X's over using opposite operations. Much less work, much less math to show here. Again, we cannot combine the X and the Y terms. So negative 14X, positive 12Y, and that equals negative 3 on the right side. And that is our final answer. Okay. Next one. Y equals negative 3/8 X plus 9/5. What are we multiplying by? What's that else? We have two fractions here. So what's the smallest number that both 8 and 5 can go into? 40. Okay. So we are going to multiply by 40. That is going to cancel out both denominators at once. Everything gets multiplied by 40. Y times 40, negative 3/8 times 40, 9/5 times 40. Numbers get a little bit big here. Okay, but we can handle it, right? Do the math. Negative 3/8 times 40 over 1 gives us negative 120 over 8, which simplifies to be what? Negative 15. Okay? If you want to, and some of you were going this route, which is great, we can rewrite 40 as 8 times 5, which allows us to do what with those 8s? Cancel them out, and negative 3 times 5 gives us negative 15. That keeps the numbers a little bit smaller. Okay, but ultimately, negative 15 is going to be our coefficient. Then we go to 9/5 times 40. 9 times 40 is 360. Oh my. 5 times 1 is 5. What's 360 divided by 5?
72.
I heard someone say they're lost. Who is lost?
No, I said a lot.
Oh, a lot. Yes, it is. Okay. We could rewrite 40 as 5 times 8, which means we could do what with the 5s? Cancel them out, which means we have 9 times 8, which gives us 72 directly. Multiple ways to get the job done here. Okay. But it starts with knowing to multiply by 40, because that's the least common denominator between 8 and 5. How you do that, that's up to you. I got the work here. Okay? Questions on this before we go on? Y 40, Y negative 15, Y 72. This is the hard part here. Okay? All right. So then we've got Y times 40, which is 40Y, negative 15X, plus 72. Almost there. Last step, opposite operations, move the X term over. Unfortunately, it's not going to be 55 anything. We have to keep them separate. It's just going to be 15X plus 40Y equals 72. How are we doing? Good? Okay. Pretty much lost? Who's pretty much lost? Priya, tell me where. Where did I lose you?
Like everywhere.
Do you understand why we multiply by 40?
Yeah.
Okay. Do you understand why negative 3/8 times 40 brings us to negative 15. Okay. 9/5 times 40 equals 72. You're good there? Okay. So do you see where we got this equation from?
Yeah.
Okay. Do you see why we added 15x to both sides?
Yeah.
Okay. I'm lost where you're lost.
I don't know. It just doesn't make sense.
Math doesn't ever make sense.
It's just like I don't understand why I have
How is this you?
to do all this stuff. So one
Oh, so it's the reason why.
Yeah.
Gotcha. The reason why is because when you're working with an equation, right, you have the option to work with it in any form that's going to make your life easier. When we want to graph an equation, it's easiest to be in slope-intercept form because it gives us the y-intercept. It gives us the slope, right? Pretty easy. Okay. When you're working with that very same equation and actually plugging numbers in for x and y, right? It's a lot easier to plug numbers in for x and y and not deal with fractions. Negative 3/8 times, let's say x is 17. Negative 3/8 times 17 plus 9/5, solve for y. Look, that's not easy to do. Whereas just plugging this in here, 17 in for x, it's a much easier equation to solve. So it depends on what you want to do with the equation, but first we have to learn how to put it in this form. Then we'll work with the equation. Okay? So the reason why, we haven't really gotten to the why yet, but this is an easier form to work with if you're just plugging numbers in for x and y. Okay? So, but the process make sense. Okay. Tatum, was it you that said this made a lot more sense last year? Yeah, last year you didn't have the double denominators, right? So that's the extra step. What?
We did this last year?
Yes. It was a CO 35. It was a kind of an introduction to it. All you had one fraction to work with. Now we're doing two, which is why it seems more complicated. Plus, I'm also trying to show you the math behind the math, so you make those connections that'll apply to other things that we do later on. So anyway, no homework for tomorrow. Well, hold on. Hold on. I retract that statement. Yeah, tomorrow we're doing. Yeah. Okay. Okay. Yeah, no homework for tomorrow. We'll cover the second half of this, which is to go from standard form back to slope-intercept form. So that, folks, is how you math.